For confidence intervals for means with one sample, for state, it's going to look a little different than our hypothesis state, okay? So instead of saying we will test, because we're not testing a claim, we're actually estimating a number. So we will estimate the true mean mu of whatever it is we're talking about, and then we're going to put what the confidence level is. That's how we do state for confidence intervals. So we will estimate the true mean mu of whatever it is at whatever percent confidence level. That's state. Easy peasy, no big deal. Plan is going to look super familiar. Random, 10%, and the normal condition. Obviously, random and 10% is just like it was with proportions. However, the normal condition, like we talked about yesterday, it is very different. We're not going to be using n times p. So, first thing you're going to do is think to yourself, hey, did that problem tell me that the population was normal? If so, you just write that down and you're done. If it didn't tell you, but your sample size is bigger than 30, then the central limit theorem applies and you're good. But if both of those are not true, then you get to make a box plot or a dot plot. Most people like box plots because your calculator will do a box plot for you. So most people do a box plot. All right, so there's that. And that's always super exciting, okay? So that is how you do plan. And then for the do, that's when you just go to your calculator and you get to use your calculator to calculate the interval. All right, it is called a one mean t interval. Okay, the technical name is a one sample t interval for means. You can shorten that to a one mean t interval. Your calculator is going to just call it a t interval. Okay, so we'll get to that in a minute. You are going to write down the values of n, x bar, and s sub x. So you're going to write those down under do along with the interval that your calculator is going to give you. The conclude statement. This should look familiar. We are blank percent confident that the interval from blank to blank captures the true la-di-da-di-da-di-da. Do you guys remember that statement? That's the conclusion statement for a confidence interval state plan do conclude 4-step process. Okay? So we kind of already know how to do most of this stuff. So really the only thing is, how do I do it on my calculator? Because I'm guessing you guys want to use your calculator. You don't want to hand calculate this stuff?
That would be helpful.
Oh, okay, cool. So let me show you guys how to do that. And then we will do a couple of examples today. All right, cool. So on your calculator, here's where you're going to go. You're going to go to stat, test, and this one is number 8, which is called a t interval. Stat test 8, and this is called a t interval. So if you guys will actually do me a favor and go there now, because I want you to see what I'm talking about when I'm doing this next part. So go ahead and go to stat, test, and number 8 for t interval. Go ahead and pull that up on your calculator. It is going to look a little bit different than what you're used to, and that's okay. It's not hard. It's asking you, first of all, what is your input? Like, what input are you going to give your calculator? It has 2 options listed for you. It says either data or stats. Either data or stats. Now, depending on which one of these you choose, it's going to change what you have to put into the calculator. So I'm going to talk about data first of all. When you have individual data given to you in the problem, okay, this is when you have your data is input into L1. Do you guys remember how to put data into L1 in your calculator? Stat edit, right? So if you are given individual data in the problem, you probably are going to be here using the data option. Now, if you're on the data option, it then asks you, hey, where's your list? Well, obviously, you should have already put it into L1 if you're on this screen. It should already be in L1. It asks you what's your frequency. You're just always going to leave that at 1. We're never going to change that. These problems, we just use it one time. And then it asks you for your C level. Now, that's just your confidence level that the problem asks you to use, and make sure it's as a decimal, so 0.95, 0.9, whatever it might be. And then you would hit calculate. I will tell you guys that your calculator at that moment has to do a lot of work. It has to take everything that's in that list and average it. Find the standard deviation. Then it has to find the T-star critical value. Then it has to calculate the confidence interval. So you're actually going to see your calculator kind of go blank for a second, and then it will pop up. It's quick, but don't be in a rush. Only hit calculate one time. You'll see this happen later, okay? All right, everybody go over to stats and hit enter so that it will select stats. This is the option you're going to use if the problem gives you all of the summary statistics. Okay, so this is when given summary of data. And in the problem, it would tell you all of the information that your calculator is asking for. It's going to tell you X bar, S sub X, N, and the C level. And so you just basically transfer that from the problem into the calculator and hit calculate, and it'll give you the interval that it's from. Okay. So those are the two different options. We're actually going to do one of each today. That way you guys can see how that works and also go through the process of the state plan do conclude, and then we'll be done. Sounds fun? You're so excited. All right, let's do it. Reagan believes that students at McKinney Boyd High School spend way too much time on their phones and other devices. To investigate, she estimates the mean amount of daily screen time for all students at McKinney Boyd High School by taking a random sample of 50 students. She finds the average daily screen time for those in the sample is X bar is 7.1 hours with a standard deviation of 2.4 hours. We are going to construct and interpret a 90% confidence interval for the mean amount of daily screen time for McKinney Boyd High School students. When you guys see construct and interpret, that means use your 4-step process. What are the 4 steps of the 4-step process?
State, plan, do.
Let's go. It's time to state. All right, so we will estimate. We are not testing. This is not a hypothesis test. We are estimating something. We are estimating screen time. So we will estimate the true mean, mu, screen time for MBHS students at 90% confidence. Guess what? That's all you got to write. That's it for state. There's nothing else to do for state. There's no null hypothesis because this is not a hypothesis test. This is a confidence interval. There's no, we defined the parameter already. Mu is the true mean screen time. So that's it. We got our confidence level. We're good. That's state. We're done. Ready to plan? Let's do it. Plan. All right. We need to check random. Do we have an SRS? Bless you. Bless you.
Yeah. It's the SRS of 50 students.
Perfect. We have an SRS of 50 students. Perfect. What's next? Yep, 10% condition. We need to make sure that 10 times the sample size, which was 50, is less than the population of MBHS students. Do you guys think that there is more than 150 MBHS students? Or 500? It's 500.
Yes.
I can do math. 500. Do you think there's more than 500 MBHS students? Yeah, I would say so. So we're good there. All right, now our normal condition. Again, we are not going to do large count because that is only for proportions. We are focusing on means. That has nothing to do with large count condition. Okay, so I want you guys to get in the habit of thinking of them in the order that they're listed on your cheat sheet here, okay? So, first of all, did the problem tell us that the population was approximately normal? No, so we got to go to our second option. Does our sample size, is it bigger than 30?
Yes.
Yes. You guys, that's awesome. N equals 50, which is greater than or equal to 30, so CLT applies. Boom, done. Take that. Any questions about the state or the plan or any part of those two? Cool. That means we get to do. It's time to do. Let's do the do. All right. So for do, we're basically going to go to our calculator and we're going to put in all of the stuff that we know. So everybody go to Stat Test 8. Stat Test 8. Now, were we given individual data or were we given summary statistics?
Summary stats.
Yeah, so we need to go over to stats. Okay, now it's asking you for some things, and yes, you do need to write down and define what you're putting in. So X bar, what was the X bar that was given to you in the problem? 7.1. S sub X, what was that?
2.4.
N, what was your sample size?
50.
And what is your C level? 0.9. Remember, you got to put it in as a decimal, so 90 is 0.9. You do need to write those down under do. So you have to be able to define what you're putting in. And then once you hit enter, again, give your calculator a second. Don't be too impatient. Some of you guys get really impatient and start hitting enter too quick. It'll make it go away if you do. So just one time and then chill. I mean, it's literally a millisecond, but it does seem like forever. So you get an interval. And what is the lower boundary of the possible screen time at McKinney Boyd High School?
6.531.
And what is the upper boundary of the possible screen time at McKinney Boyd High School?
7.669.
There we go. And now we can conclude. We are, what are we? 90% confident that the interval from 6.531 to 7.669, what does that interval do?
Captures the true mean.
So, yep, hang on. Captures the true mean screen time at McKinney Boyd High School. We are 90% confident that this interval captures the true mean screen time at McKinney Boyd High School. Questions, comments, concerns? So for our follow-up question, it says here that a recent report stated that U.S. teens have 6.7 hours of daily screen time on average. Does the interval from Part A provide convincing evidence that the mean at McKinney Boyd High School is different from the national average? So if the national average is 6.7, and you have the confidence interval that should capture McKinney Boyd High School screen time, are we different?
No.
Nope. Why not? Boom. You guys are so smart. Since 6.7 is in the MBHS interval, we do not have convincing evidence of a different value. Cool. And now for the best part of the day. Do you guys know how to check your screen time?
Yeah.
Oh,
Go ahead and do a little checky check. What is your average daily screen time?
5 hours. 4 hours and 48 minutes.
5 hours, 4 hours. What's it under? It's under settings and then what?
And it's
Screen time.
Oh, it literally just says screen time. Settings and screen time.
Oh, now it's 5 hours.
5 hours. 5.
12 hours and 57 minutes.
I'm sorry?
12 hours and 57 minutes.
12 hours and 57 minutes?
That's actually.
How did,
What?
that's 7 hours to from?
How many hours are you
13.
I had 7
Hours
hours,
No, mine's 3.
but not hearing that.
Well, I would challenge you guys to try to decrease your screen time, especially you.
I can't.
Mine has stated 5 hours.
No, she's been wondering.
Yesterday was 7 hours.
All right, you guys. So, all right, next problem. Here we go. Next problem. Anybody ever heard of this guy named Michael Jordan?
No.
No, never?
Michael B. Jordan?
He got to like say.
Oh, y'all are funny. All right, many people believe that Michael Jordan is the greatest basketball player of all time, with a career scoring average of 30.1 points per game. Some curious students wondered about his scoring average for his home games. They decided to take a random sample of 15 home games from his career. Here is the number of points he scored in each of those games. And we have the data listed here for us. We're going to construct and interpret a 95% confidence interval for the mean number of points that Michael Jordan scored in all of his home games. All right. So, I have good news and bad news. The good news is this works pretty similarly. The bad news is you were given individual data, which probably means something. No, it's not 2, but it probably means that you're going to need to put it in the calculator.
But do you have to do it
Does it matter what order?
It does not matter what order. So go ahead and put this data into the calculator. Might as well get it in there because you're probably going to need to for possibly a couple of different reasons. So, stat edit. Stat edit. We're going to go to L1. And we're going to plug in this data. It does not matter what the order is. Now, you don't have to do anything with it just yet, but at least the data's in the calculator for when we're going to need to do something with it, which will probably be soon. All right. State. We will estimate the true mean, mu, number of points that, you can just say Jordan if you want, that Jordan scored at home games at a 95% confidence level. Stat edit. Mm-hmm. Okay, and there's state. So we're going to estimate the true mean number of points that Jordan scored at home games at a 95% confidence level. All right, what's next?
Oh, we plan.
We're going to plan. Okay, so random. Do we have an SRS?
Yeah, random sample of 15 home games.
We have an SRS of 15 home games. 10% condition. 10 times the sample size, which is 15, that's 150. Do you guys think that that is less than the population of Jordan's home games over his whole career? Mm-hmm. All right, normal. All right, let's go through the list. Does it tell us that his home games are approximately normal?
No.
Nope. Is our sample size bigger than 30?
No.
No. Guess what? No. We get to make a box plot. Here's the good news, you guys. The calculator does it for you.
That's great.
I know, right? All right, so here we go. Grab your calculator. I'm going to go through the steps. You ready? Grab your calculator. I'm going to go through the steps of making sure you know how to do a box plot. Here we go. Ready? Second, y equals. Turn on that first stat plot. So hit enter on 1 and hit enter on. Now you need to make sure that you have the box plot selected that shows the outliers. It's the fourth option for the graph. Okay? Second, y equals. Yeah. I got nothing there for you. All right. And then make sure you turn on your box plot. Make sure you've got the fourth box plot selected, the one that shows the outliers. And then you're going to hit graph. You're probably not going to see anything. And you're going to hit zoom 9. Zoom 9. You should see a box plot.
What do we do again when you press second Y equals?
Second y equals, hit enter on number 1.
Yeah.
Turn on the box plot. So hit enter on. Make sure you have the fourth graph selected, the one that shows box plot with outliers. So you got to hover over that and hit enter. And then you're going to hit graph zoom 9. Yes, sir?
I'm just getting an error.
Huh?
I'm just getting an error.
What does it say?
It's the second one.
Yeah, I don't think I'm.
Do you have data in your stat edit? You have to put the data in, otherwise there's nothing to make a box plot of.
I choose the fourth one, what do we do? Like if after we choose the fourth one?
After you choose the fourth graph, you hit the graph button, and then you hit zoom 9. What error are you getting, any? Did you hit zoom 9? Okay, go back to second y equals. Make sure to hit enter on number 1, and make sure you hit enter on. And then graph zoom 9. Okay, you guys, there's a box plot. Aren't you excited?
No.
Why not? And now we get to draw it. So, I need you guys to hit trace. Hit trace. If you hit left and right, you're going to see the minimum, the Q1, the median, the Q3, and the maximum. Now, what's the minimum number?
24.
24.
Okay, so you've got it on, but you need to select the box plot. And so what I did is I hit down, and then you have to hit the right arrow over, and then hit enter on that box plot. Graph, zoom, 9. Okay. If you hit trace, you're going to be able to see the lowest number in the dot or in the box plot, and then the highest number. And what is your lowest number in your box plot? 24. And what does it need to go up to? 38. You can go by twos if you want.
Wait, how do we find the minimum and maximum?
Hit trace and hit the left and right arrows. All right, so your minimum was 24, yes? What was Q1, quartile 1?
27.
27. What was a median?
31.
Q3?
35.
Yeah, 35.
And maximum was 38? So, looky there. We have ourselves a box plot. Question. Does that look pretty normal to you?
Yeah.
Looks pretty doggone normal to me. Do you see any strong skewness?
No.
Do you see any outliers? Then that means that the T procedures, the T distribution is, you can use it, okay? So that's all we have to notate here. We say no outliers, no strong skewness. So T procedures apply. Yay, you guys, that means we get to do the do. Whoop, whoop. You guys are loving this, aren't you? It's like McDonald's. I'm loving it.
Wendy's is better. Am I right? Yes.
You guys, I really wish that y'all could see the look that Abigail keeps giving me over this whole box plot situation. If looks could kill, I would be on the floor. All right, cool. Everybody good? Are we ready to do the do? All right, here we go. Let's do the do. For do, this is where we just basically go to our calculator. You guys are already on your calculator, so go ahead and go to stat. Go to stat test 8. It's the same one, but this time, do we have data or do we have statistics? We have data this time, so make sure the data is selected. Now, you don't have to put anything else in because it's in L1. You're just using the frequency once. The only thing you need to make sure of is your confidence level is correct. What confidence level is this problem about? 95. So you need to put in a 0.95 under your confidence level, your C level. And then your calculator, again, it's going to take a second for this to pop up. Because when you hit calculate, it has to calculate the mean of all those numbers, the standard deviation of all those numbers, the T-star critical value, and it has to do the formula for the confidence interval. That's a lot of work. So it does take your calculator like half a second, and so don't go too fast. All right, you guys, what is the interval? 2?
32.8630.
Okay, now, because it wasn't given to us in the problem, and even if it was, we would need to rewrite it anyway, but we do want to go ahead and write down what the x bar and the s sub x were here in this section. So what was x bar?
30.53.
30.53.
Yep.
S sub x?
4.21.
Okay, and our sample size n was 15, and our C level was 0.95. Okay. Time out, quick question. 30.53, where is that going to be located in that interval?
Right in the middle.
Right in the middle, because remember the interval is x bar plus or minus the margin of error. So there you go. If you needed to get the margin of error, could you get it?
Yes.
You sure could. All you'd have to do is find the difference between the middle, x bar, and either of the endpoints. Guess what? It's time to conclude. We are, what are we? 95% confident that the interval from 28.204 to 32.863 captures the true mean number of points Jordan scored at home games. What do you guys think? Not too shabby, not too shabby.